So this lecture is going to be starting our review on the final exam, and I'm going to cover problems here tonight that you may see that you will most likely see on the final. They'll since it's all going to be online now, I don't know exactly how they may or may not change the format or the wording of questions, so that's always a kind of a variable there. So I'm going to show you problems here from exams 1 and 2, the material from exams 1 and 2. And then next week I will go over questions that you have from this video, and I will show examples of exam 3 material next week. So please keep in mind while you're going through this and while you're working on the review for the final of any questions that you have, so I can answer them on next Tuesday or Wednesday's video. And I will send out a review that will have all the info on it. So, example 1, let's find the domain, and here's part A. Now you have to ask yourself, remind yourself, what is the domain? The domain is the set of x values that this graph can use, or this graph touches. So if we were to look at a graph, let's say first, here's the x-axis and the y-axis, and let's say we have this graph. So the domain here, it's all the x values that this graph uses. So start with the smallest value, which is over here. It keeps going down to negative infinity. So that is the smallest value. And then you go to the largest value, and it goes, and this x just keeps going and going and going to positive infinity. And since we're here, I should have wrote this in the directions. Let's find the range. So the domain is the set of all x values, and the range is the set of all y values. And this one's pretty easy here. The smallest y value goes to negative infinity, and the largest is positive infinity. Alright, let's look at one more graph, and then we'll get on to how to find the domain of a function. Of just having an expression. So here's our, and then let's say we have, let's do this, and this is at 1, negative 1, and then at 2 we have another dotted line there. And what are those dotted lines called? Dashed lines. Those are, this is a vertical asymptote, and this is a horizontal asymptote. So our graph will never touch those points, or those dashed lines. So you could have something like this. And I hope you can see this, the colors at least. I think it's all right. All right, so pause the video and give it a try. I encourage you to do that anytime. All right, so let's start with the domain. So the domain, I need more room. We'll do the domain at the top. Domain. So remember, the domain is all the x values that this graph uses. And so start with the smallest x value. So here's my x-axis, and so it looks like two separate graphs, but it's one function. It's still one graph. So my graph over, it keeps going to negative infinity. So that's my smallest value. And then it goes, then we're coming from negative infinity, and we're moving, the graph goes up vertically right here. And it will get closer and closer to, but it will never touch this vertical line what is the value of this vertical line? It's -1. So that is the next value. And we use a parenthesis or a bracket. Remember, a parenthesis means we don't include that point. A bracket means we include it. Here we're never going to touch this -1 line, so it's a parenthesis. And we have this portion also we have to worry about. So we have these x values, and then we skip a point, and we have these x values. So remember the U shape, it just means this and this is in the domain. Then we pick back up all the way down here at -1. And then it goes, follow the graph, and it goes to infinity. So if you notice, all this is saying is that the domain is -infinity to +infinity, but we're just leaving out -1. That's why we have a parenthesis here on -1. It was never going to touch it. So that represents that line there. Now try the range. Pause the video. I'm going to go ahead and go though. The range. Alright, the range, you start with the smallest y value, which this graph goes down here, and it keeps going down to -infinity. And then it goes up, keep following the graph, and then it levels off right here at this dotted line, dashed line, which is what value? It's 2. So it's never going to get to 2. So we use a parenthesis. And so we have this portion, and we have this range to take care of. So union or and. Then it picks back up here at 2, and then it keeps going up to infinity. And again, that's saying that the range is -infinity to infinity, but we're leaving out 2. So what we want to look at now, we're going to keep it the same. We're going to just say find the domain. And we're only going to find the domain now, because the range is a little harder on these problems. Let's say you had f of x is equal to x squared minus 3x plus 8. Alright, so this is one of those that I told you that you're just going to have to remember. And I'm going to let you in on a trick, or a secret, not a trick. You're going to have your calculator there for the exam. Especially when you get to this domain section, the calculator is going to be helpful. So all you have to do is plug this into your y equals, and then hit the graph button, and it will graph and show you what the graph looks like. It will show you it has asymptotes, and so on and so forth. So when you plug this in, think about it. We talked about this a lot. This is a parabola. It's a U shape up or a U shape down. You know it's a U. You know it's an up cup or a up U if A is positive, which here it's 1. If this was negative or less than 0, it would be down. So here we're going to have a up U, and the x values are -infinity to infinity. This will always be the case. As long as it's on, as long as we have, integer numbers, there's no square roots, there's no fractions, we're always going to have all real numbers. Alright, what about part D? Let me get my example here. What about, let's call it g of x is equal to 3x over 7, sorry, 2x minus 4. Okay, so if we have something like this, you could plug this in to the calculator, or if you remember, and if you plug in the calculator, you'll see that it has a vertical asymptote at x equals 2. But remember, when you're finding domain and vertical asymptote, they're the same thing. Domain just one step further. The next step is just writing what the domain is. So for the domain and vertical asymptote, we always set the bottom equal to 0 because that will tell us where this function's undefined or where that vertical asymptote lies. So we set the bottom equal to 0, add 4, and divide both sides by 2. So x is equal to 2. This would be your vertical asymptote, which is this. In this example, it was -1. So over here in this example, when we found the domain, we left out -1 up there. So it's the same thing here. This is our vertical asymptote. It's that dotted line, and the domain is every number but this one. So it's all the numbers except that vertical asymptote. So the domain is just -infinity to 2, not including it, union 2 to infinity. Alright, and let's look at one more over here that will be helpful. E, let's call this h, the square root of x minus 5. So if we have a square root, ask yourself, what can we not have inside? What can we not take the square root of? What can we not have on the inside? We can't have a negative number or anything less than 0. So we always want the inside of that square root to be greater than 0. And that's what we do here. We say greater than or equal to 0. So we say x minus 5. We take the inside, and we want it to always be greater than or equal to 0. Because those are the only numbers that we can take the square root of. And so the square, don't let the greater than or equal throw you off. You just need to know that if it's a square root, you need the greater than or equal, and you treat it as an equal sign at this point. So you add 5 to both sides, and so you get x is greater than or equal to 5. From here, you can find you can write the domain. So this is saying x greater than or equal to 5. So you want all the x values greater than or equal to 5. So ask yourself, is 6 greater than 5? Yes, it is. So that's the direction we're going. We want 5 to infinity. That would be our domain. So the domain, start with the smallest value, which is 5. And do we include it or not include it? Since it's greater than or equal, we include it. And then 6, 7, 8, 9 to infinity is greater than. So we know we're going the correct way. On the test, if it's multiple choice, and again, I don't really know exactly what they're going to do. I assume they have to do multiple choice, but I'm kind of in the dark right now because they haven't gave me any details. But if it's multiple choice, you can eliminate the wrong answers. So the advice I'm giving you right now is based on the old final exams from when we were actually in class. And on most of the problems, you can narrow down each question to 2 or 3 answer choices. And sometimes you can narrow it just by marking all the ones that you know are wrong. You could just be left with one answer, which would be the correct answer. So always look at that first and see which ones. Always look at that and see which answer choices you can mark out because you know they're already wrong. That is a big help, especially if you're going to wind up just guessing. Which it happens, I understand. One last note here about domain and range, in particular domain on these types of problems. You plug it in your calculator. You could plug part E in your calculator and you would see the graph starts at 5 and it keeps going to the positive infinity side. So keep that in mind. Jot that down as a reminder. You will be allowed to use the calculator, and so use it to your advantage. Next, let's call this example 2. Find increasing, decreasing constant. And I may or may not show an example of constant. That's pretty easy. It's just a straight line. So part A, in fact, well, let's see. Here's the x-axis. I don't have a lot of room. Y-axis. I'm not going to show a constant because I'm confident you can figure that one out. But let's do this. That is supposed to be an arrow. Alright, and you have to know some values here because we're doing increasing, decreasing, and constant. So let's call this point here 2. 1, 2, 3. This is 2, 3. It may not, on the test, they may not label it like this. I'm just doing it because I'm a terrible drawer, and so you can see, your graph. This is 2, 3, and let's call this one 1, 2, 3, 4. 1, 2, 3. So this is 4, -3, and this is -2, 3. All right. So pause the video, but I'm going to go ahead and keep going. All right. So we want to find the increasing, decreasing, and constant. So what we do here is, remember the little man we talked about walking. You read this graph from left to right. And if you like the little man walking, he's always walking left to right also. So however you want to view it, read a book left to right, and the man walking left to right. So he's starting here and he walks up and he's going, this is uphill. So this is the increasing portion. And then as you get to here, you start walking downhill, decreasing. And then you go back to increasing. And that's pretty simple. That's pretty much how you do it. Now this is very similar, increasing, decreasing, and constant is very similar to domain. But the main difference is in increasing and decreasing, we always use parentheses. And I'll get to that in a second. I'll say more about that in a second. So let's look at increasing. So my smallest value of increase, it's increasing on this portion. So it starts at -infinity and it increases up to what x value? This -2. So -infinity to -2. And then I'm increasing again here. So it starts at what x value? 4 to +infinity. So union 4 to infinity. Alright, and then decreasing x values. It goes from -2 all the way to 4. So by doing this increasing, decreasing, and constant, you gather all of the x values that the graph uses, and they're all represented here. But other than the actual point here and here. The reason we use parentheses, meaning not to include these points, is because we don't know what's actually happening at these points. We don't know if they're increasing or decreasing. So what we do, we call this the relative min, and this is the relative max. Alright. So on the exam, they may say, they may ask you about relative max and mins. You just need to know that. They'll word it. Previously, they worded it a little differently than you may have seen. So I'll just give you one example of how they did it in the past. They say f, which we'll call this red function f of x. F has a relative min at x equals 4. So that's this point here I identified. I said f has a relative min. I'm just abbreviating relative and minimum. It has a relative min at x equals 4. So that tells you it's this point here already. And so the next portion I'm going to write can you can throw you off a little bit. You just have to make sure this next portion matches up with your y value, which is -3. So this is how they write it. So f has a relative min at x equals 4, comma, the relative min is -3. So just be aware of this. There'll be several things on the exam worded differently than you've seen in the past, but you know the material, all the material you've seen before. And this is one of the examples. You haven't seen an answer choice like that, but this is how they write it for whatever reason. But you know the material, it's there. You just need to slow down, process a little bit. You say f has a relative min at x equals 4. You say, okay, that's right. Here's my relative min, and the x value is 4. And then the next part says the relative min is -3, which what that is identifying is it says y equals -3, which that's true. So that would be my answer. Okay, next up is, we'll say example 3, I think. Anyways, determine if the function is even, odd, or neither. So I'm just going to abbreviate by saying even, odd, neither. Alright. And here's part A. If you have f of x equals let's call it 3x to the 5th minus 4x cubed plus 7x. Alright, so here, some of you may remember how to do this already, and that's great, and if you know the fast way, that's good. You can use that to your advantage. The way you determine if a function's even, odd, or neither is you look at all of their exponents. You look at, so this is one term, the second term, and the third term. You look at the exponents. The exponent here is 5, which is odd. Exponent here is 3, which is odd. Exponent here is 1, which is odd. So this would be an odd function. But if we're going to work it out algebraically the way we did in the past, I just want to review this real quick, because the answer choice again is going to be different than what you've seen before. So f of -x, that means, so every time you do one of these problems, you plug in -x into the function, and then you simplify it. So you get this. Hopefully that's clear. Blue's getting a little run out. Alright, so what does all this mean? And I showed you this in class, but I want to show you one more time. And let's just take this so I can show you how to simplify these negatives raised to a power. Let's take -x cubed. So if I have -x cubed, well, if I was to write that out, that means I have -x times itself 3 times. So -x times -x times -x. Alright, so let's say negative times a negative is a positive, positive times a negative is a negative. So whatever my answer is going to be negative in the end. And then x times x times x is x cubed. So -x cubed. Similarly, if you have, let's say, if I had an even exponent, and all these work exactly the same way. You just need to know if it's even or odd, and you can determine the end result. This says you have -x times itself 2 times. -x times -x. Negative times a negative is a positive, so my answer is going to be positive. then x times x is x squared. Alright? So what this tells me, or tells us, is that if you have an even exponent, the negative inside just gets eaten away. Even exponent, the negative gets eaten away. Even eaten away. If you have an odd, then it moves, the negative comes outside of the parentheses and moves to the front of the term. And I'll show you what I mean on this example. Alright, so remember, even, the negative gets eaten away, so it just disappears. But the odd, the negative stays there and just moves to the front of the term. It comes out of the parentheses and to the front. So here I have negative x to the 5th power. 5 is odd, so that means this negative stays, but it moves outside of the parentheses to the front of the term. So now this becomes negative 3x to the 5th. Alright? And then here is minus 4 times negative x cubed. The 3 is odd, so I know this negative has to stay in here, and it just comes out of the parentheses and moves to the front of this term and changes that sign. So it's a negative, so this negative coming out makes that a positive. 4x cubed. And then here I have plus 7x to the 1st power. I know 1 is odd, so that negative stays in there, moves to the front of the term, and changes this sign. Because a positive times a negative is a negative. So negative 7x. And then what you do from here is you compare to the original equation. Did this sign change? Yes. Did this one change? Yes. And did this one change? Yes. So all the signs changed. That means it's odd. Alright? And so let's write that. Odd means all signs change. Even means no signs change. Alright. So here, this is odd. And on the exam, you could, if there's 5 answer choices, 2 of them could be odd, and you know the other 3 are wrong. So at least you narrow down your choices there. But what they add on a little bit extra here. They add on the actual definition that we went over in class, and what that is they say they both start out the same way. G of negative x is equal to something. And then I need a different. That's alright, I'll just erase this. So they both start out the same, g of negative x. So all that's saying is you're plugging in negative x into the function g, f, it doesn't matter what this letter is. So what happens let's start with even. What happens with an even function when you plug in negative x? What happens to if you have an even exponent, what happens to that negative? It gets eaten away. So none of the signs change, and you wind up with the original function, just g of x. That's what it means to be even. Now, if it's odd, you plug in negative x. What happens when you have odd exponents? That negative moves to the front. Same thing here. This negative moves to the front. So negative g of x. So the same principle works. You have negative x inside the parentheses, and it's an even function, so it gets eaten away. And you wind up with, it just goes away. If you have an odd function, that negative on the inside moves to the front of that term, which is what you get here. So what they're going to want on the exam is they're going to say odd, and then they're going to give you different choices for these. So you have to know those. Odd because g of negative x, let's see, I know it's odd, and I know that if it's odd, that negative just stays in there and moves to the front of that term. Alright. Put that on your flashcard or note card or however you need to do it. Alright. So let's look at now Well, I think looking at how to find vertical and horizontal asymptotes would be appropriate since we've kind of talked about them a little. Example 4. Please excuse me if I get the example number wrong. I lose track of that easy. Find the VA. Find the vertical asymptote. I guess it could be plural. And here's part A. We'll do 2 of these. So let's do 2x divided by x squared minus 25. It looks kind of bad. X squared minus 25. Alright, we already talked about this. Finding the vertical asymptote is very similar to finding the domain. And in fact, this is even shorter than finding the domain. You set the bottom equal to 0, solve for x, and out pops your vertical asymptote. Alright, add 25 to both sides, and square root both sides. So x is equal to 5. And so this is actually your vertical asymptote. VA is x equals 5. But this would be the trap answer. Because anytime you introduce this square root, like we did here, we didn't write it, we square rooted both sides, you have to account for the plus or the minus. The plus and the minus. That's because, think about this. If I were to plug both of these numbers into this equation here, x squared is equal to 25. Well, a positive 5 squared is 25, and a negative 5 squared is 25. So, think of it like that. Always check yourself. Alright, I don't think there's a reason to try another one of these. Again, if you have issues with something I'm going over, you need another example, just you email me before I make my video next week. Alright, now let's look at horizontal. Horizontal asymptote, example 5. Find HA. Here is part A. Let's say we want to find 3x squared plus 1 divided by 4x squared minus 3. Let's not use 3. Let's use 5, just to keep numbers different. Alright, so what we want to do is we want to look at the degree of the numerator and the degree of the denominator. The degree of the numerator, the top, remember what the degree is also. The degree is the highest exponent. So the degree of the top, its highest exponent is 2. The degree of the bottom is 2. So if the degree of the top and the degree of the bottom are the same, then you take the coefficients of those two. You take the leading coefficients of the top and the bottom. So this says y equals 3 divided by 4. So your HA is 3 over 4. Alright, well what happens if they're not the same? I knew you were thinking that, so I'll help you out. B, let's say you have 3x squared plus 1 all over 4x cubed minus 5. So the only thing that changed is this 3 here. So the degree of the top is now 2, and the degree of the bottom is 3. So the top's bigger than the bottom. So what we have to do is we have to make them the same. We make them the same by adding in an x cubed term on the top. And what coefficient would we give it? A 0. Because 0 times x cubed is still 0. So we're not changing the equation here. 0 times x cubed. I didn't change anything. I just added that in, which is just 0. So now that they're the same, I take their coefficients, 0 divided by 4. So y is equal to 0 over 4, which is 0. And your HA is y equals 0. And then there's only 3 options here. Part C, let's call it 3x cubed plus 1 all over 4x squared minus 5. Okay, so now the degree of the top is 3 and the degree of the bottom is 2. And I'm just now realizing that doesn't look much like an exponent. Now it's so small you can barely read it. But anyway, so that's a 2. So now, since the degrees are not the same, I need to make them the same by adding in an x cubed on the bottom with the 0 as its coefficient. So now that they're the same, I just take their coefficients, 3 divided by 0. Y is equal to 3 over 0, which is undefined, does not exist. DNE is fine. DNE means does not exist. So no HA. And those are your 3 options for horizontal asymptote. Okay, so this next problem I'm actually not looking forward to doing, mainly because of my board space. And you'll remember it once I start going over it, but it's been a while, and it was from the first exam. So go back and look at the example or the problem I gave in exam 1. But example 5. Find the difference quotient. The difference quotient. And that is f of x plus h minus f of x all over h. Alright, so it's a long process. It's fairly simple. It's a long process, but you'll see the same patterns every single time you work one of these. And as I go through, I'll remind you of those patterns. Alright, so let's look at an example of something you might see on the exam. So find the difference quotient of, let's say, f of x equals x squared minus 3x plus 2. So just made up something there. Alright, so I want to find the difference quotient of this thing. Now if you remember, the first thing we normally do is we write the formula, which is this big long thing here. We're going to. But to make our lives easier, we want to find out what this f of x plus h is first. So we do some side work to find that, and then we start plugging everything in. So find f of x plus h first, then plug into formula. Okay? So to find f of x plus h, we have f of x plus h. That's equal to, so this is telling you to take x plus h and to plug it in the f function everywhere there's an x. So x plus h, this becomes x plus h, this becomes x plus h, and this becomes x plus h. So you get x plus h squared. Hopefully this is coming back to you slowly. Minus 3x is now x plus h, and then plus 2. Plus 2 started floating on me. Plus 2. Now multiply this out and simplify it. This is why I say do side work, because it gets long. So this portion here you should be good with, but I want to show you the side work of how to get that. So it's actually, now we're going to do some side work of the side work. I can do this in my head just because I've done it so much, and hopefully eventually you get that way. But if not, that's okay. Just know that this is what we have. X plus h squared means we're multiplying x plus h times itself twice. So x plus h times x plus h. And then from here, you can multiply using the box method that we talked about. So where we draw a box with 4 squares and then we put x and h and x and h, and then you multiply the intersection of everything. If that's the way you feel comfortable with, then do that. But all you do is you take this first term, which is x, and you multiply it to both the terms over here. So x times x and then x times h. And then we'll move on to this h and multiply it to x and to h. All right. So if you take it step by step, you take x times x, which is x squared, x times h, which is x plus, x times h. So now you move on. H times x is hx, which you can write as xh. Since you're multiplying, you can write them in any order you want. And then h times h is h squared. So this is x squared, and then you have 2x plus 8. You have 2 xh's now. And then plus. Alright. Again, you can write this on a little flashcard or whatever so you can help yourself with it. Alright. So this x plus h squared portion becomes this thing. So x squared plus 2xh plus, I wrote that wrong, 2xh plus h squared. So this became this. And then distribute this -3. -3 times x is minus 3x. -3 times h is minus 3h. And then we still have this plus 2 out here. So this big long thing is now what goes into f of x plus h. Alright. So what I'm going to do is erase this. And I'm going to erase this up here in purple, but I'm going to rewrite this formula just to give myself a little bit more room. So here we have f of x plus h minus f of x all over h. This is equal to, and I'm going to try to combine the boards into one here. I'm going to write and skip over. So f of x plus h is this thing here. So I'm going to write that first. So this is yeah, I'm gonna have to just skip over the board. So x squared plus 2xh plus h squared minus 3x minus 3h plus 2. So that is just the f of x plus h portion. So here this is supposed to be conjoined. Alright, this is just the f of x plus h, and then it's minus, and you know you're going to have this big divide sign with an h on the bottom. So this is f of x plus h, this is the division line here, and then this h is this h. So now we have this minus sign that's part of the equation of f of x. And I already erased f of x, which is not good. Sorry. So f of x was x squared minus 3x plus 2. Alright, so it's just asking us to literally plug in what f of x is here. So this is f of x is x squared minus 3x plus 2. Alright, hopefully that's clear enough. And then, so what's going to happen is you're going to start seeing a pattern start falling out here, and that pattern will be broken up because of a mistake I made at this step here. So I'll get to the pattern here in a minute, and then hopefully you'll be able to diagnose your own problems eventually. So you look at this formula. It's minus, this minus sign here is minus this f of x. It's minus this whole thing. So whatever I plug in here for this f of x, it's still got to be minus that whole thing that I plug in. So I plugged in this x squared minus 3x plus 2, and this minus sign is still, it still has to be minus this whole thing. So you have to have parentheses here. That will get you. But there's a saving grace, because in a couple steps you wouldn't be able to simplify the problem any further, and I'll show you that now. So this is equal to, so I know I have this big divide sign here. I'm going to try to make this as easy to read as possible. This h stays here, and so the only thing I'm going to do in this step is distribute this negative in over here. So nothing else has changed. It's just going to take this negative, and now it's going to be there. So I'm just going to alright, so distribute this negative, so now I get minus x squared plus 3x minus 2. Now, here's step number 1 to help check yourself. This whole f of x that we just plugged in, this x squared minus 3x plus 2, and now we distribute that negative. All three of these terms right here should cancel out with other terms in here. So let me show you. Here you have a minus x squared, and here's a positive x squared. So these cancel. That becomes just 0. Here you have a positive 3x and a negative 3x. So those cancel. Here you have a negative 2, and here's a positive 2. So the way you check yourself at this step to see if you're doing it right so far is the whole f of x, these last terms that were f of x should all cancel out at this step. And then in the next step, what you should be left with, every term in the top should have an h in it. So we're left with, and in fact, I'm going to just write it over here because it's small enough now. 2xh plus h squared. I'm losing track of myself with this gap. And then minus 3h divided by h. Alright. So notice all the terms in the top, or the numerator, have an h in it. And that means we're still going on the right track. So all these terms should cancel in this step. All the terms here should have an h in them. So this term has an h, this has an h, and this has an h. Now all the terms in the top have an h, so factor out one of those h's. Factor out an h, and this is a must step here, unless you're just very, very comfortable with doing this. You have to factor that h out of all those terms, and when you do that, you get h divided by h, which is just 1, so those cancel. So I highly encourage you to do that step where you factor out an h, because it's going to save you a headache down the road. So what's left, your answer is 2x plus h minus 3. Next, we want to look at the composition of functions. And you will remember this as we go over it. But again, look at exam 1. There was an example on there. There was also the reviews I sent out for exam 1 that will have several problems on there for you to try. So I have no idea what example I'm on. We'll just call it 6. I could be wrong. So it will say something along the lines of, let's say, given f of x equals 4x squared minus 3 and g of x equals 2x plus 5. I get a little messy. 2x plus 1 is fine. Find f of g of x. Alright, so first we need to recall what f of g of x means. So we have f of g of x. That means we can rewrite this as f of g of x. So we're plugging the g function into the f function. So simplify things. We know what g of x is. G of x was given to us. It's this 2x plus 1. So f of 2x plus 1. What is f of 2x plus 1 telling us? That says to plug this 2x plus 1 into the f function, where there's an x. So here's the f function. This x now is 2x plus 1. This x now is 2x plus 1. And then minus 3 still. So, if it helps, you can do this. And you probably don't have to erase, I'm just doing it just to have more room. F of 2x plus 1. So if it helps, you can write the f function on top. So f of x is equal to 4x squared minus 3. So now you know this x is this 2x plus 1. And now this x becomes 2x plus 1. And so you have 4x, but that x is now 2x plus 1. And that's squared minus 3. It's a little blurry. I'll write it a little bit bigger. Hopefully that's a little better. So now you have to simplify this 2x plus 1 squared just the same way we did a second ago. Here's the side work for it. 2x plus 1 squared. And this time I'll do the box just to show different ways. Remember, this 2x plus 1 squared is the same thing as 2x plus 1 times 2x plus 1. So you put 2x 1 here, 2x and 1 here. So this is the intersection of these two things. So 2x times 2x is 4x squared. This box is 2x times 1, which is 2x. This box is 1 times 2x, which is 2x. And this is 1 times 1, which is 1. So that means I get 4x squared plus 2x plus 2x plus 2x plus 2x and then plus 1. Alright, I could have got ahead, and then you combine these two to make 4x. So I didn't write this very well. 4x squared plus 4x plus 1 is what we place over there. And remember, this is only this 2x plus 1 squared portion. That 4 is still there. So there's a lot of 4's here. Alright, so let's try this. That 4 is still on the outside. Now that 2x plus 1 squared becomes this. So 4x squared plus 4x plus 1 minus 3. And now we're going to distribute this 4 into all three of these terms. So now you get 4 times 4x squared is 16x squared. 4 times 4x is plus 16x. 4 times 1 is 4. And then the minus 3 is out there still. And then 4 minus 3 is the last thing that we can combine here. So your answer would be 16x squared plus 16x plus 1. Alright. Now let's look at how to find the vertex of a quadratic function. Example 7. Find vertex of f of x equals negative x squared plus 2x plus 3. Alright. So first, can you tell me if this vertex is going to be a max or a min? The way you tell is, but you look at a, and a is the coefficient attached to the x squared. So it's -1. If a is negative, that means it's a downwards cup. And so you have a point at the top, which makes it a max. If it's a is positive, then you have a cup, an upwards cup, and it gives you a negative. So here we're going to have a maximum. And to find the vertex, you do, it's a point. It's negative b over 2a, comma, f of negative b over 2a. Which all this is saying is find negative b over 2a and then plug that into your function. So we need to first find this negative b over 2a. Negative b over 2a. So I would recommend doing it like this every time. You have this divide sign and you have the minus. That's all part of the equation. And so now we need to find b. You come over here and b is 2, positive 2. And then the bottom is 2 times a, and a is -1. So this gives you -2 over -2, which is a +1. So this tells you that negative b over 2a is 1. So now you can replace that in these two spots. So you get 1, comma, f of 1. So the last thing to find now is what f of 1 is equal to. So f of 1, that just says we're plugging 1 into the f function. So everywhere there's an x, it's now a 1. This is a 1, this is a 1, and this is a 1. So we have negative 1 squared plus 2 times 1 plus 3. And so that gives me negative 1 plus 2 plus 3. And that winds up with 4. So my vertex, 1, 4. What I'll expect on the final would probably be a word problem, maybe. You just have to recognize that they gave you a quadratic and maybe some bigger numbers than what you have here. But just it's really just recognizing that you need to find the vertex. This, if it's negative in the front of the x squared term, then that's going to give you a maximum profit or a maximum height of balls thrown, something along those lines. All right, the next thing will be to determine multiplicities of zeros. Let's do this. Example 8. Find zeros and multiplicities of, and let's say I'm going to go ahead. Normally in class and on the exam I showed you something that wasn't factored, but here I want to show you a problem that's already factored, just so I can hit the highlights here of and refresh you on how to find multiplicity. So let's say you have x plus 3 to the 5th power times x minus 7 cubed times x plus 2, no, x plus 4 squared. So here I already gave you something factored out, and this is just to hammer home the meaning of multiplicity. So if I wanted to find multiplicity, I first need to find the zeros. And multiplicity tells me what's happening at those zeros. If it touches and turns around at that 0, or if it goes through the x-axis at that 0. So let's start. We set this thing equal to 0. So equals to 0. And now we can set these separately equal to 0. So I get this. Alright, use a different color here. Now, to get rid of this to the 5th power, we do the 5th root on both sides. So the 5th root of 0 is just 0. So this winds up just giving you x plus 3 is equal to 0. And the same thing with the cube. You do the cube root of 0 is 0. So x minus 7 is 0, and x plus 4 is 0. So subtract 3, you get x is negative 3, x is equal to 7, and x is equal to negative 4. Those are our zeros. Now we have to determine the multiplicity of these zeros. And you do that by coming back up to this step right here. And really you can go to this step too. But as long as those exponents are still in there, that's all that really matters at this point. Alright, so where did this x equals negative 3 originate from? It originated from here. And what is the exponent of that x plus 3? It's 5. 5 is odd, so that means this is odd multiplicity. Odd multi. I'm just going to abbreviate. Odd multiplicity. And what does it mean to have odd multiplicity? Odd multiplicity means that it goes through the x-axis at this point, or crosses the x-axis at this point. So crosses x-axis at -3, 0. Alright, let's keep going on. Now, where did this x equals 7 originate from? It originated from this term here. What's its exponent? It's 3. 3 is odd. So this is odd multiplicity. So it crosses x-axis at 7, 0. And I could have combined these into one, but alright, and then last one. Where did this x equal -4 originate from? It came from here. Its exponent is 2, which is even, so it's even multiplicity. Even which means it touches and turns around at that point, or it's tangent to. So either way you want to write it. I'll just do touches and turns around at -4, 0. Alrighty. Example 9. We're going to look at possible rational zeros, or the PRZ. So example 9. Find possible rational zeros. And I label them as the PRZ. You probably won't see that anywhere else on the exam. But it's, just do it for shorthand. PRZ is equal to this. So the top is the factors of the constant term, factors of the constant, divided by the factors of the LC, the leading coefficient. Alright, so let's make one of these up real quick and see what we get. This won't be given to you on the exam, you'll have to know that. Let's just say our function is this. Let's do something somewhat simple, short. 2x cubed minus 7x squared plus 8x minus 17. Alright? So to find the PRZs, we need to find the factors of the constant term and divide each of those by the factors of the leading coefficient. So over here, my PRZ is equal to, and here's my line. So what are the factors of the constant term? Which one is the constant? It's this -17. So we don't have to worry about the negative because we account for the plus and the minus of every single factor, no matter what. So we just need to look at what the factors are of 17. Well, the only thing that multiply to give you 17 is 1 times 17. And that's it. Nothing else will do it. So plus minus 1, comma, plus or minus 17. That's what goes on top. Now on bottom, the factors of the LC, which is the leading coefficient. It's the coefficient attached to the degree term, 2. So the factors of 2 are 1 and 2. Those are the only things that will multiply to give you 2. So plus or minus 1 and plus or minus 2. So what you do is you take each term in the top and you divide it by every term in the bottom. So start with this plus or minus 1. Plus or minus 1 divided by each of these, and then you move on to the next term on the top. Alright? Plus or minus 1 divided by plus or minus 1, comma, plus or minus 1 divided by plus or minus 2, comma. So now we exhausted all our options on the bottom. Now we move on to the next term in the top, plus or minus 17. So plus or minus 17 divided by plus or minus 1. And then plus or minus 17 divided by plus or minus 2. That equals, so simplifying this, 1 divided by 1 is just 1, plus or minus 1. 1 divided by 2 is 1/2, so we only need to write the plus or minus 1 time. 17 over 1 is 17, so plus or minus 17. And then 17 over 2 just stays 17 over 2. Alright, example 10. And we're going to use synthetic division now. And the remainder theorem all in one here. So example 10, use synthetic division and the remainder theorem to find the indicated value. Alright, so this is roughly what they'll say online or on the final. And this is kind of how they'll have it laid out. Let's say this is -3, 1, -2, 3, and -5. Now I'm just making up numbers here. And this is how they'll have it set up. They'll say use synthetic division and the remainder theorem to find the indicated value. Then they'll give you a setup of synthetic division just like this. And then below that they'll say by the remainder theorem find f of -3. Alright? So this is by giving you the -3 in the box and telling you to find f of -3, you're doing the same thing. If you work through synthetic division, your remainder, whatever your remainder is here, is your answer. That's why it's called the remainder theorem. Also, if you were to plug -3 into the original function of this, you would wind up with the same answer. So let's just run through it real quick and also refresh. So you start off by bringing the first number down, which is 1. 1, and then whatever's down here, you multiply it to the box. 1 times -3 is -3. And we always add down. So this is -5. -5 times -3 is a +15. Add down gives you 18. Alright. Then you want to do 18 times -3. 18 times -3 is -54. And add down, which gives you -59. So -59 would be your answer here. F of -3 equals -59. Alright. They may just have -59 written as the answer also.